The balloon does not compress when the piston is pushed as the air escapes from the front, keeping the atmospheric pressure the same. The balloon compresses when the piston is pushed and the opening in the front is blocked, increasing the amount of atmospheric pressure. What and why? The balloon remains the same size when the pressure decreases and volume increases. This, however, is not the same when the pressure increases and the volume decreases. This experiment explains the inversely proportional relationship between the absolute pressure and the volume of a gas explained in Boyle's law. Hi guys, good afternoon. I'm Jetnel V. Antonio and I'm going to explain to you the Boyle's law. But before that, I'm going to give you some background about Boyle's law. In 1662, Robert Boyle discovered that when held a constant temperature, the volume and pressure of a gas are inversely proportionate. Put simply, when the volume goes up, pressure drops, and vice versa. The mathematical equation is equally as simple. PV is equals to K, in which P is equals to pressure, V is equals to volume, and K is equals to simply as constant. So that's it. This has become a basic principle in chemistry, now called Boyle's law, and is included as a special case into the more general ideal gas law. The equation for Boyle's law, so let's erase this one. The equation for Boyle's law is P1 V1 equals to P1 P2 V2, in which P1 is equals, or let's say this is a initial pressure, V1 is an initial volume, and P2 is the final pressure, and V2 is the final volume. So let's try a problem. So let's say a balloon contains 7.2 liters of helium. The pressure is reduced to 2 atmosphere and the balloon expands to occupy a volume of 25.1 liter. What was the initial pressure exerted on the volume? So let's find out the given. What are the given? So let's say this is 7.2 volume, this is initial volume V1, and the pressure is reduced to 2 atmosphere. Let's say 2 atmosphere is final pressure, or P2, and the balloon expands to occupy a volume of 25.1 liter. Let's say this is final volume. So let's go back to our general equation, which is, what's our general equation? P1 times V1 is equals to P2 times V2. So now we have already the given and the equation. So let's substitute the given into our equation. So it will be simply as P1, which is unknown, right? P1 times V1, which is 7.2 liters, and then is equals to, what is our P2? 2.00 atm, and then times our V2, which is 25.1 liter. So to solve this equation, it will be P1 is equals to 2.00 atm times 25, let's say 5.1 liter over 7.2 liter. Right, so the unit liter will be cancelled out, right? Cancelled out. So P1, our initial pressure is equals to 6.97. What is the unit left? ATM. ATM. So that's it. This is our initial pressure, 6.97 ATM. So that's how easy, guys. So you try also. Thank you for listening.
Good afternoon to everyone. This afternoon, we will discuss how to solve the Charles law and the Gay-Lussac law. So my friend here will show to you how to solve and the formula of this problem.
One. Charles law. Charles law is between the relationship between the volume and temperature. So volume is directly proportional to temperature. Here's a sample problem. A gas in a container has an initial volume of 7 liters and an unknown temperature. The final temperature is found to be 250 Kelvin with a final volume of 12 liters. What is the initial temperature? So first, identify the given. Given are 7 liters for the initial volume. Second, 250 Kelvin for the final temperature. Then, the 12 liters for the final volume. So the required is the initial volume, or the initial temperature. So the formula is initial volume over initial temperature is equal to final volume over final temperature. So initial temperature is equal to initial volume multiplied by final temperature over the final volume. Then substitute initial temperature is equal to 7 liters multiplied by 250 Kelvin over 12 liters. Cancel the liters. So the answer is equals to 146 Kelvin. Yung pause mo lang. The Gay-Lussac law. Gay-Lussac law is also directly proportional from the relationship of pressure and temperature. So here's an example problem. A sample of gas is placed in a container at 25 degrees Celsius and 2 atm of pressure. If the temperature is raised to 50 degrees Celsius, what is the new pressure? First, identify the given. Given are 25 degrees Celsius, that is the temperature 1 or the initial temperature, but in solving gas laws, it is need to be converted to Kelvin. So add 273 is equals to 298 Kelvin. Then the 2 atm is the partial or the initial pressure, 2 atm, and plus is the 50 degrees Celsius, which is the final temperature, but we need to convert in Kelvin, plus 273 is equal to 323 Kelvin. So the required is the pressure final. So the formula is initial pressure over initial temperature is equal to final pressure over final temperature. So substitute P2 is equal to P1 multiplied by T2 over T1. So if P1 is equal to 2 atm multiplied by 323 Kelvin over 298 Kelvin. So cancel the Kelvin. P2 is equals to, or the final pressure is equal to 2.17 atm.